I'm Nick Pilgram.
And I'm Ian Powell.
And this is our project, the Sound Cartographer. So here is a picture of our project, the Sound Cartographer. It's based on using the Arduino. It's a pretty simple project. What we have here is a circuit that measures sound intensity using an inverting amplifier and a microphone. And that relays that to an Arduino in addition to a GPS module that gives latitude and longitude data, and all that is combined and written to an SD card, allowing us to do sound mappings. Here is a fritzing diagram of our circuit. It looks pretty similar to what you just saw. Here's the sound part, microphone and the inverting amplifier. We have the Arduino here. We have our GPS and our SD card. So here is the basis of the main electronics of the project is this microphone sound input and then the inverting amplifier to be able to get a usable signal. Down here's a diagram. As you can see, we have our mic. It's just running off a simple voltage divider that has to take out the signal from the microphone. We needed to amplify it though, so we had to run it through an inverting amplifier here we made with the 741 op amp. The current configuration that the inverting amplifier set up in gives us a gain of about 15,000, which allows us to pick up some pretty casual conversation and whatnot. Very, very good. But the key component here is this capacitor, because we had to kill off the DC component to feed it into the inverting amplifier for it to work.
So here's our Arduino code. We include the tiny GPS library so that we can get the latitude and longitude of our location using the GPS module with our Arduino. Essentially what we do is we take our inputs and we take the sound, so we initialize with these pin modes here, and over here in our main void loop we open up a file called out, and we basically say, well, we can take GPS data, get the latitude, longitude, and age, which is an unspecified variable. But we're particularly concerned with the latitude and longitude here, so we print the longitude, the latitude, and the sound level from pin 7 to our SD card in a CSV file.
So here is some results from one of our sound mappings. So I took out the Sound Cartographer, turned it on, and took quite a long walk around the Cal Poly campus here. You can see the exact path I pretty much took around the campus. There's a nice color mapping here, so you have the areas where you had more sound occurring. We have some darker areas over here. I know interesting one that happened is I went by a weed whacker right here, so you can definitely see that there's a sharp sound increase, as well as along the roads here we had various cars passing me as well, and that's how you can tell you have the larger amounts of sound there on the mapping there. So it does a pretty good sound map. In addition to having this visual representation of plotting the data, we also have, if we go to the next part, we have imported it into Google Maps here. The link to get to this actual map is in the description of the video below, and it's directly in Google Maps. You can do both satellite and non-satellite view, and if you click on any of the bubbles here, it'll give you the exact sound intensity that we had at that very exact location.
So here's the little walk that I took on Higuera. And as you can see, we had little blips of intensity here and there, which were either due to loud conversation outside of storefronts or motorcycles. In both situations, the Cal Poly campus mapping and here along Higuera, what I did was I did a data smoothing because we were taking so many data points and some of them had some noise. So I'd average out the points around an area and take that average location and the average sound intensity and plot it here in this color scheme that you can see. And again, this is the Google Maps mapping of my walk, and around 12 p.m. so it wasn't too noisy, but yeah. Finally, you get to see it in action.
Our Sound Cartographer in action. Not too much going on. Taking sound data right now. It's not going to be very good because we're currently talking, so not realistic. But here it is.
In action.